A very good day to y'all, and in this video we will see what is the Brewster's law. So according to Brewster's law, let's consider one boundary. This boundary is separating the surface 1 and surface 2. So let's consider one ray of light which is hitting the boundary. After it hits the boundary, what will happen is that some of the light will get reflected and some of the light will get refracted. Now let's consider the light which is vibrating in a plane which is moving towards you and going away from you. Therefore we have drawn a circle over here, that is a dot, and the another plane of vibration of a light is in the vertical direction. So in this way the light will come and hit the boundary. After it hits the boundary, it will get reflected and refracted. Now what Brewster said is that if this reflected light and refracted light make an angle of 90 degree, both the light will be polarized light. So the reflected light will be having a plane of polarization, plane of vibration, which is coming towards you and going away from you, and this refracted light will have a light vibrating in the vertical direction. So over here, in both the refracted light as well as the reflected light, you have got a plane polarized light. So now let's derive a formula for this. Let's draw a normal to this surface. Over here, if you observe that this is the angle of incidence, I. But since we are getting two polarized lights, therefore simply we write it as IP. Now we all know that the angle of incidence is always equal to the angle of reflection. Therefore this will also be IP. And the another one, this is the refracted angle, and we write it as RP. Now if you all see this whole angle, this is nothing but 180 degree, and this 180 degree consists of this IP, this 90 degree angle, plus this RP. So over here we get one equation, that is the 180 degree angle is formed by IP plus 90 degree plus RP. Now from this, if you take IP and RP on this side, what we get is that RP is nothing but equals to 90 degree minus IP. So this is the angle of refraction which we have got. Now according to Snell's law, how we find the value of mu is that mu is nothing but equals to sine IP, that is the angle of incidence, upon the sine of angle of refraction. But from this condition what we have got is that RP is nothing but equals to 90 degree minus IP. So substituting this value of 90 degree minus IP in this equation, what we get that as mu is nothing but equals to sine of IP upon sine of 90 degree minus IP. Okay, now we can also write this sine of 90 minus IP as the cos of IP. Therefore mu now becomes sine of IP upon cos of IP. Now we all know that the sine upon cos is nothing but equals to tan of IP. So this was the derivation for the angle for the refractive index of a plane of a surfaces which give us polarized lights. So guys, thanks for watching this video. Do subscribe to the channel and do like the videos and share with your friends. Comment below if you all feel that something must be improved, and In the playlist you will find all the videos of 11th and 12th science as well as engineering, physics and chemistry. So guys, thanks for watching this video. Thanks a lot.